Welcome back to the Deep Dive. You hand us the sources, and we bring you the clarity. Today, we are opening up a topic that is keeping pretty much every CIO and CFO up at night. We're talking about the cost of the AI revolution.
It's really more than just a cost at this point. It's a systemic risk. We're diving into what the industry is now calling the AI infrastructure reckoning. And the core finding from the material you shared, it's basically a warning siren for the entire Global 1000.
Yeah, and we need to hit that statistic right out of the gate because it really defines the whole challenge. IDC is predicting that major global companies are set to underestimate their AI infrastructure costs.
And not by a small amount.
No, by 30% through 2027. 30%.
Wow.
I mean, that is not a rounding error. That's a massive structural gap in financial planning.
It signals a fundamental disconnect, really. And I think our mission for this deep dive is to understand why the traditional budgeting playbook, the one every finance team has mastered for decades, is now completely obsolete when it comes to managing AI.
That's such a critical point. When IT leaders budget for, say, a new ERP system or a big cloud migration, they're dealing with projects that are expensive, yes, but they're highly predictable. The licenses, the seat count, the depreciation schedule.
Exactly. But AI, it's a completely different animal. The IDC research points out that AI is expensive, it's unpredictable, and it's resource consumption. It's just growing far faster than most budgets can track. The expense isn't just a number on a spreadsheet, it's a living, breathing, and wildly variable thing.
Okay, so let's start right there. Why do these costs defy traditional budgeting? What are IT leaders tracking, or maybe what are they failing to track that makes the old spreadsheet useless?
Well, the complexity is, it's opaque. Even for very experienced IT pros, you're not just tracking a server rack anymore or a software subscription. You're tracking these tiny granular components, specialized GPUs, inference cycles, networking costs, and even the smallest unit, the token.
That level of granularity, it feels like trying to measure water usage by the droplet. It must be exhausting for a finance team.
It is. And the real killer is the scaling dynamics. This is where the traditional linear cost assumptions completely fall apart. The sources warn us that when you look at certain large language model, if you just double the size of that model, you don't double the compute, you can consume up to 10 times the compute.
10 times.
10 times.
So the cost curve isn't a gentle hill, it's a cliff. If that's the case, what should IT leaders be tracking right now to spot that jump before it just destroys their budget?
They need to see utilization, not just allocation. They have to move past, we bought X GPUs, to how saturated are those GPUs at any given moment.
Yeah.
And if you're building models, you have to track the rate of complexity increase versus the actual performance improvement.
Right.
If doubling the complexity only gets you a 2% bump in performance, that project's a massive liability.
And the cost doesn't just stop once the model is trained, which I think is a mistake a lot of leaders make. They budget for the build, but they forget about the upkeep.
That is the critical distinction. Once you train a model, the heavy lifting doesn't stop. You immediately move into the inference phase, the actual use of the AI. And those inference workloads run continuously. They are just sucking up GPU cycles 24/7 long after that initial training cost is done.
It's a great analogy, but it also sounds terrifying for a CFO who's trying to guarantee a predictable return on a huge investment.
It is, and that's why AI applications are being compared to a living organism. They're constantly growing, adapting, and draining resources in ways you just can't predict. If you treat it like a fixed asset, you are going to run out of road fast.
Okay, let's talk about the resources that aren't even raw compute. What are the hidden cost centers that IT leaders consistently underestimate, especially around, governance and safety?
Well, everyone remembers to budget for security and, some basic employee training. But what organizations consistently overlook are the vast, complicated supporting systems you need to reduce risk and ensure compliance once the AI is actually live.
Okay, so when we talk about reducing risk, what specific infrastructure are people forgetting to budget for?
It's the infrastructure for monitoring the logging systems, the drift detection engines.
What's that?
That's what tracks when a model starts giving unreliable answers. And then you have all the validation checks. These systems are what make the AI safe and fair and reliable, but they all consume compute themselves.
And how significant are those costs, really?
They are massive. We see specific data from major enterprises showing that these safety layers, these supporting systems, have grown to cost as much as, or in some cases, even more than the actual model inference
Well,
itself.
hold on. The safety net costs more than the thing it's designed to catch.
That's right.
That is staggering. Why? Why is that the case?
Because you have multiple checks running constantly on these really complex data pipelines, you have redundancy built in for every stage. So if you have an LLM deployed, you need external checks, validating its outputs, ensuring it follows policy. That process, repeated millions of times a day, is incredibly computationally expensive.
And I imagine this hidden cost is then compounded by the inevitable scope creep. The new AI tool built for the product team suddenly becomes a shared service for marketing, HR, customer support.
That's the internal viral factor. An AI project budgeted for 50 people is suddenly serving 5,000. The demand spike is completely unforeseen, and the entire cost model just collapses. It's the kind of runaway success that ironically breaks the budget.
So we've established the internal AI economy is unpredictable. It's nonlinear. But that's compounded by this staggering amount of capital being poured in at the top of the supply chain. Let's talk about the vendor spending frenzy.
Yeah, if you look at the macro picture, the scale of investment by OpenAI, Anthropic, AWS, Microsoft, Google, it's adding immense upward price pressure on every single component you need for AI.
And the sources bring up frankly, some frightening numbers here, specifically from IBM's leadership.
They do. IBM's CEO, Arvind Krishna, he sounded a major alarm bell. He was talking about the sheer fuel needed to power these ambitions. He said just building 100 gigawatts of data center capacity to keep pace with demand.
And the projected cost for that global build?
About $8 trillion in capital expenditure.
$8 trillion.
$8 trillion. And Krishna was very clear. The math, as it stands, just doesn't add up. To make that viable, you'd need about $800 billion in profit just to cover the interest payments. That kind of return just doesn't exist in the data center market right now.
$8 trillion is a number so large it almost loses meaning. It sounds like the cost of building a small country.
And IBM's COO, Barry Baker, reinforced this. He noted that a single 1-gigawatt data center will likely cost more than $75 billion. This hyper-aggressive investment means vendor demand is just outstripping supply everywhere.
Which means inflated prices for everything. The people, the concrete, and most critically, the specialized silicon, the advanced UPUs.
Exactly. And this vendor frenzy highlights another long-term financial trap for enterprises, the hardware refresh cycle. AI isn't like standard IT where you can sweat an asset for 5 or 6 years. This hardware will need to be replaced every few years to keep up.
So it's not a one-time sunk cost. It's a guaranteed staggering reinvestment cycle every, 36 to 48 months? If the math doesn't even add up for the vendors, why should a CIO trust that the market won't just pass all that cost inflation on to them?
That's the crucial point. They have to assume vendors are trying to recoup this massive outlay. IDC's Jensen is very clear on this. The massive spending will keep prices high in the near term because they have to recover those hundreds of billions in costs. You, the enterprise consumer, are currently funding the vendor's gold rush.
Is there any good news? Is there a point where this cost curve starts to bend back down?
There is hope, but you have to have strategic patience. The prediction is that past 2027, we should see AI infrastructure prices start to fall. This is expected to be driven by, reductions in GPU prices as the tech matures. And eventually, vendors will have to cut prices to stimulate demand.
So until 2027, IT leaders are basically fighting an uphill battle. This brings us to the mandatory solution for managing the risk: financial operations or FinOps. And this is no longer optional for AI, is it?
Absolutely not. IDC sees FinOps as the essential solution. We're seeing FinOps teams reporting directly to the CIO's office now, which shows you how critical it's become. The need for it really stems from the philosophical change that AI demands.
Let's dig into that philosophical shift, because this is where the organizational friction really happens. You mentioned moving from predictable to probabilistic. What does that mean for, a traditional finance department?
It means letting go of the comfort of annual fixed budgeting. Traditional tech spending was predictable. AI consumption is probabilistic behavior. It depends on user adoption, model complexity, external data. So because of this uncertainty, financial visibility can't be a quarterly exercise anymore. It has to be continuous. It has to be built right into the operational loop.
It sounds like it forces the finance team and the engineering team to finally speak the same language. That's easier said than done.
It creates enormous friction. Traditional FinOps often just allocated costs. AI FinOps requires shifting accountability for costs back to the business units actually consuming the AI. If the marketing team's workflow doubles consumption, they need to see that cost immediately and have the levers to adjust. Engineering is responsible for efficiency. Business units are responsible for spending.
So good FinOps forces leaders to focus on AI projects with the best ROI probability and to adjust costs on the fly.
The ability to adjust is paramount. The advice is to look for easy wins, but there's a huge caveat. What's easy at one company might be impossible at another. So leadership also means looking outside. If your competitors are losing money on a project, learn from their mistakes. Don't repeat them.
Okay, speaking of going deeper, traditional FinOps is about tracking costs. But to survive this reckoning, you have to go much deeper. You have to look at how the models actually perform and find where you're wasting resources in the architecture itself.
This is the move from basic cost tracking to advanced cost engineering. FinOps teams need to start using operational analytics. They need to see not just how much money is being spent, but how the engineering workloads are operating in real time. Are the GPUs sitting idle? Is a validation process running too often?
Which brings us to some immediate viable strategies, starting with model right-sizing.
That's the first line of defense. The default strategy is often, let's use the biggest, most powerful LLM we can find. Instead, you have to guide teams to use the minimum size model available for each specific task.
And the beauty of that is, a lot of the time, requests can be rerouted to smaller, more specialized models without hurting the user experience at all. It's just pure efficiency.
Precisely. And that efficiency extends right into architectural optimization, especially with GPU utilization. This is where a huge amount of capital is being wasted right now.
How so?
GPU nodes are frequently operating at just a fraction of their total capacity. Poor scheduling, a lack of consolidated workload management, they're waiting for tasks or running things one after another instead of at the same time, better orchestration, better workload placement, making sure those incredibly expensive GPUs are running closer to 100% saturation, that can save a substantial amount of money immediately.
And we have to revisit those hidden supporting systems we talked about. If they can cost more than the AI itself, they need optimizing too.
Absolutely. The FinOps team has to systematically evaluate the design of those retrieval systems, the validation pipelines, the policy checks, make sure they aren't running more frequently than the underlying data actually requires. Every unnecessary validation cycle is just money down the drain.
So finally, what's the overall strategic advice for CIOs planning their next 3 to 5 years, keeping that 2027 price drop in mind?
The first piece of advice from IBM specifically is to adopt hybrid architectures. Do not overcommit to a single AI infrastructure provider. Vendor lock-in here is just incredibly expensive.
Okay, so stay flexible.
Exactly. Second, focus on technical efficiency. Use techniques like quantization and compression to make models smaller and faster. Deploy smaller, fine-tuned models for specific jobs. Don't just default to the biggest general-purpose LLM for everything.
And the third piece of advice goes back to the broader market context. Strategic patience.
It's a difficult pill to swallow when you're under pressure to modernize, but it's critical. Avoid investing in capabilities you don't need yet. Let the early adopters, the ones paying these inflated prices, absorb the penalties of being too early. Learn from their expensive mistakes before you commit your own budget.
So what does this all mean for you, the listener? The core conflict of this AI infrastructure reckoning is this. The AI revolution requires you to pivot immediately from the comfort of predictable budgeting to the challenging world of continuous, probabilistic financial management.
Understanding that living organism nature of AI costs, that non-linearity of consumption, that is the singular key to successful digital transformation here. If you rely on the traditional playbook, you will inevitably be one of those companies underestimating the expense by that critical 30%.
And that brings us to our final provocative thought for you to chew on. The long-term prediction is that prices for AI infrastructure will eventually fall past 2027. But given the staggering $8 trillion vendor bet on data centers and the constant need for short-cycle hardware reinvestment just to keep up, how long can enterprise budgets actually afford to fund this massive short-term infrastructure gold rush? That funding gap, that is the real source of the reckoning.